So today we're having k times k times k plus k equals to 10. So we say solution if we have k, let's raised to power 1 times k raised to power 1 times k raised to power 1 plus k also raised to power equals to 10. We can recall that when a is raised to power 2 times a raised to power 1 is equal to a raised to power 2 plus 1, which is equal to a raised to power 3. So that way we can say k 1 plus 1 plus 1 plus k is equal to 10. K raised to power 3 plus k therefore is equal to 10. And we can write k raised to power 3 plus k minus 10 equals 0. We are going to split 10 so that when we write one of the number in an index form, it will give us a power of 3. So what comes to mind is 2 and 8. 2 plus 8 is 10. 2 is written as 2 raised to power 1 and 8 is 2 raised to power 3, which is power 3, like we have k as 3 and this k is raised to power 1. So our equation becomes k raised to power 3 plus k raised to power 1 minus 2 plus 8 equal to 0. So k raised to power 3 plus k raised to power 1 minus 2 raised to power 1 minus 2 raised to power 3 is equal to 0. So if we continue with this, we are going to group them according to their powers, that is k raised to power 3 minus 2 raised to power 3 plus k minus 2 is equals to 0. So k raised to power 3 minus 2 raised to power 3 plus k minus 2 is equal to 0. And remember algebraic identity that says a raised to power 3 minus b raised to power 3 is equal to a minus b, a squared plus ab plus b squared, where our a is k and b is 2. So our equation becomes, we want to apply this in this form, it will be k minus 2 into k squared plus ab is k times 2, which is 2k plus 2 raised to power 2 plus k minus 2 equal to 0. Now we have k minus 2 and k minus 2. We can bring it out to have k minus 2. At this time, divided by k minus 2, it will be left with this one, k squared plus 2k plus 4. 2 raised to power 2 is 4 plus k minus 2 divided by k minus 2 to be left with 1 equals to 0. And if we simplify further, we have k minus 2 into k squared plus 2k plus 1 equal to 0. K minus 2, here we have k squared plus 2k plus 4 plus 1, 5 is equal to 0. And now we can say that either k minus 2 is equal to 0, or k squared plus 2k plus 5 is equal to 0. And from here, k is equal to 2. The first value of k. And here we use a quadratic formula that says k is equals to minus b plus or minus square root of b squared minus 4ac over 2a, where our a is equal to 1, our b is 2, and c is 5. So if we substitute our value, k will become minus 2 plus or minus square root of 2 squared minus 4 times 1 times 5 all over 2 times 1. So k will be equals to minus 2 plus or minus square root of 2 squared is 4 minus 4 times 1 is 4 times 5 is 20 over 2. So our k will be equals to minus 2 plus or minus square root of minus 16 over 2. K will become equal to minus 2 plus or minus square root of minus 16 all over 2. So the next line will be k equals to minus 2 plus or minus square root of minus 1 times 16 all over 2. That is the same thing, minus 1 times 16, the same thing as minus 16. So, but square root of a times b, same thing as square root of a times square root of b. So our k will becomes k equal to minus 2 plus or minus square root of minus 1 times square root of 16 all over 2. And here we have square root of minus 1 to be I. In place of minus 1 we put I. Therefore our k will be equal to minus 2 plus or minus I square root of 16 all over 2. And the next line will be k equals to minus 2 plus or minus 4i. Square root of 16 is 4 all over 2. And the next line will be k equal to, if factor out 2, we have 2 here, minus 1 plus or minus 2i all over 2. And successfully you can see that 2 can cancel out 2 and give us 1. K will therefore be equal to minus 1 plus or minus 2i. So these are our final value for k. So the first value for k, k1, will be equal to 2, the one we got previously, and the second value, k2, will be equal to minus 1 plus 2i, and k3 will be equal to minus 1 minus 2i from here. So these are the three values of k that can satisfy our original equation. Thank you for staying tuned. Bye bye.